I would like to show you the capacity of machine learning in order to explain the distribution of seagrass species of the Mediterranean Sea. We utilize the dataset coming out of United Nations Environmental Program, the well-known UNEP, which explains and gives us shape files of the distribution of seagrass at the bottom of the Mediterranean Sea. And we blended this data with the data coming out of Copernicus Marine Environmental Service and the data coming out of EUMETSAT. So we were able to understand how the different environmental and oceanographic parameters are affecting the distribution of seagrass in the benthic marine environment. Here you see the different parameters that we considered. For example, bathymetry is extremely important for the presence or absence of seagrass species, but also other parameters like water temperature, salinity, chlorophyll, nitrate, phosphate, Secchitis depth, turbidity. The wave height also is extremely important, the distance from the nearest city or port, or the distance from the mouth of a river. So these parameters were considered as important, and they were imported in the model. And we, in most of these parameters, used two types of data sets, the data referring to the surface of the sea and also the data referring to the bottom of the sea, because all of the seagrass is living at the benthic environment. So as you can see here, we have static data, static parameters, meaning they don't change in time. For example, bathymetry is a static parameter. And then we have temporal parameters like water temperature, or salinity, or dissolved oxygen and nutrients that change over time, and we have to perform a different treatment for them. So on the other hand, we have a database of UNEP WCMC, which is a database of 5 main seagrass families in the Mediterranean Sea, and you see their instances and the relative percentages in the Mediterranean benthic environment. So using again machine learning tools, we were able to identify the key parameters. For example, chlorophyll is extremely important for the presence of seagrass, but also the distance to coast and bathymetry and the distance from river mouths are the main drivers. And then wave height, salinity, and temperature are affecting it, but in a lesser way. So I would say that this diagram gives us the relative importance of this parameter on the distribution of seagrass, and we have to consider that most of these seagrass species are considered as bioindicators for the marine environment. So you see here again we tested several different machine learning algorithms like passive-aggressive, the K nearest neighbors, the logistic regression, the decision trees, random forests, and the ridge algorithms, and you see here their relative performance. And you see that random forest was a numerical model that gave us the best performance. So in this example, we have identified a different machine learning algorithm that performs better for this particular case. For example, the influence of chlorophyll on and the margins of chlorophyll levels that the different seagrass species tolerate and are the favorable conditions for these seagrass species. For example, you see here that Posidonia is a seagrass species which is considered as bioindicator for clean, non-turbid waters. And you see that they like very narrow environmental conditions in terms of chlorophyll and very low levels of chlorophyll. The same for Chimodokia. Chimodokia is again a bioindicator of clean waters, and you see that they like again very low chlorophyll levels and very, very narrow change in chlorophyll levels. On the other hand, you see Zostera, for example, which is a seagrass giving us an indicator of poor water quality, and Rupia, they like a broader window in terms of chlorophyll levels. The same applies here for salinity. We have narrow banded species like Halophila that don't like salinity to be changed in time and place very much. And we have Uri-halide species that prefer to have, for example, Rupia over here. They would like to be located in areas that we have significant changes of salinity, meaning at the very close of in close proximity to the river mouths. So based on this work, we are able to understand and examine the environmental changes and environmental parameters that drive this distribution, and in the future forecast how environmental changes are going to affect the distribution of seagrass in the Mediterranean Sea.